If I wanted to do something like this, we used Rosalind's free throw shooting last day. So let's say I don't know how good of a free throw shooter you are, but I witnessed your last 100 free throws and you made 80 of them. Does that mean you are 80% for life or just 80% for your last 100?
80% from the last 100.
Yeah, that's probably safer, but maybe you're 83% as a lifer. Maybe you're 79, you're probably not too far off.
Right.
Your lifetime free throw percentage. So what we will do is take that sample and figure out how to do that cushion, the plus or minus. And I'll say, based on what we witnessed, it's safe to say that Rosalind is 80%, maybe plus or minus 5% or plus or minus 2%. Well, there's actually mathematics for this. So that's why with an opinion poll is exactly the same as a free throw. I asked 1,000 people and it was a yes or no question. You shot 1,000 free throws, you made it or you didn't. Do you understand? It's actually exactly the same thing mathematically. And I'll say, based on that, this is what I witnessed. This percentage is what I witnessed, and I'm going to do a plus or minus. I'm going to do a cushion, okay? And there, again, the mathematics is actually not that complicated. That's the whole point of today's lecture. This is what is called a confidence interval. Confidence. Probably spell it better than that. I sell this other stuff. A confidence interval. And these things are very powerful. The confidence interval is the plus or minus because it's an interval. It's everything between here and here. And in order to do that, there are certain lines in the sand. We call Z lines in the sand. So if I think of, okay, this starts with a normal distribution. And I want you to think of the tail right here. There are Z-scores, we can look them up in the table, that correspond to probabilities. For example, what if I wanted exactly, let's just say hypothetically, what if I wanted 99% of all of the outcomes that are possible? I'm going to exclude the highest 1%. Okay, because if we were talking about income and we're trying to figure where the mass is, we probably don't want to include Bill Gates. Nothing against Bill Gates, but I don't think he represents the general public. Right? Billionaires and gazillionaires probably, do you agree that they're probably not? Or if we're talking about housing, we probably don't want to include the 20-room estates that are $100 million. But just sort of in general, if I wanted, because of what I'm doing, I want 99%. So what Z value is this? Well, it's the Z value where 99% of the outcomes are below it. So if I go to my table, I'm looking up 0.9900. Where's the closest to that? Well, if you in your table, you see it's right here. Okay, everybody see it? If you don't have a table, I have some extra ones up here. I'm sorry, what? Look for 0.99. You can't find it in the negatives. Yeah, look at my picture. You're trying to find this value here, so you probably want to look at the positive Z-scores.
Professor, so just to recap, going to the right, positive, going to the left.
Well, no. The positive Z-scores are everything to the right of the middle.
Yes. That's
what you meant. Yeah.
Okay.
So if I said what Z-score is the closest to capturing 99%? Well, first of all, when I'm looking at my table, right here, that's 9898, and the next one's 9901. So that's pretty much the closest one, isn't it? That's 2.33 of a Z-score. That's 2.32. Now, you can't do this by hand, but the computer actually can generate this for us. And every stats book has the exact number. The number that we use that corresponds obviously is between a Z-score of 2.32 and a Z-score of 2.33. Does that make sense? Look at your table. I'm not calculating. I'm just looking at my table. The closest one's 99%. So the Z-score we actually use in that case, the computer generated Z-score, if we go to 3 decimal places, is universally this. You don't memorize this. Write this down. It's on your formulas. It's right here. So the way we write it, and this is really, really clever mathematics, we write it like this. the Z, and then as a subscript, it has a 1% tail. The Z that has a 1% tail, that means it captures 99% of all the outcomes, is this value. Okay. Again, the Z that has a 1% tail, 1% being 0.01, means 99% are to the left. So if somebody had a Z value, okay, in a normal distribution, it could be based on their height, based on their weight, based on a test score. If somebody's Z score exceeded this, that means they are in the top 1%. That's what it means. So we're talking about babies, you know, when we talk about, you know, you're in the 90th percentile based on your height or your weight or something, your Z score would have to be this big for you to be in the 99th percentile. So having a Z score above this means you are really, really far away. Okay. That's a value you don't calculate. That's a computer generated value. Now, the next line in the sand that I want to look at is, what if I want the 95%? I want this to include the top 5%. That means on my values, I want to find the closest number to 0.95. Okay, so if I'm looking at my table, let's see, 9495, oh, right here. In fact, check this out. See this arrow? See that little asterisk? Even in your table, you have the little arrow in the asterisk. Do you have one in your table? Yes. They're telling you, hey, look, guys, look, it's right here. It's right between these two.
What is that?
Well, this is I'm trying to find the Z value that corresponds with the top 95%. In other words, only a 5% tail. And we say tail because if I said, I want to be, we always talk about, like, I want to be in the top 5%. I want to be in the top 10%. I want to be in the top 1%. That means you're looking at it this way. Okay. This is the top 1% or 5% or 10%. So if you're in the top 5%, that means 95% is to your left.
Yes.
And that's the number we look up in the table. That's why I'm showing you how these are found. Well, this one here is considered one of the more important ones. And this one's exactly halfway between. So the Z value that corresponds to 5%, and that's on the table. You don't have to memorize these. I printed these out for you. But that one would be what? The one that corresponds to a 5% tail is 1.645. And the reason we go to that third decimal place is we don't have to do any work, so we might as well be accurate. It's the most accurate number we could use because remember, you're doing everything on a calculator. We're going to walk through all these. Now, what if, here's a different way of looking at it. I don't want the top or the bottom. I want to now I want to look at a different point of view. I want to exclude the extremes. When we're talking about human heights, if I said, well, 99% of the people or 90% of the people, whatever, pick a number, are going to be between here and here. I want to exclude the tallest people on the planet. I want to exclude the shortest people on the planet. I want to say, where are the vast majority of all human beings from a height standpoint? Okay, so now what I want to do is I want to look at this by saying, I want everybody between here and here, but I want to exclude both tails. I want to exclude the extremes. Why would I do that? Well, let's say you're a clothing manufacturer. When you think about clothing sizes, traditionally, there's usually, well, it starts with 3. What are they? S, M, and L.
Small, medium, large.
Now, I walk in, I was flipping through the channels the other day, and I got stuck. I spent about 15 minutes of my life watching, it's a really terrible movie, Adam Sandler, the one where he's in jail, Longest Yard. Okay, the remake of Longest Yard. And there's a guy there, his name was Turley, and he's like, getting him to join the team. This guy was a monster. And I thought, my goodness. So I looked him up. He was 7'2", 400 pounds. Oh. He was an Indian actor. He actually wasn't really an actor. He was a power lifter, but he played this role. This guy was one of the biggest people I've ever seen. Now, I'm going to design a clothing line. Maybe I'm going to have a clothing store. Am I making clothes for that guy? No. Why? Not because I don't like him.
Yeah.
Well, how many human beings on planet Earth are that big. Not very many. So if I design my clothing store to fit that guy, then I'm going to exclude all you guys.
Yes.
So when you're designing clothing, you're an adult clothing store. Are you designing clothing for that rare hobbit that shows up? No, because you would be spending a lot of time and a lot of money on clothes that aren't going to sell because there are very few people that small or that big. Does that make sense? Why? Oh, okay. So I want to capture the majority of the people. Okay, I don't want the XXXXL necessarily. I want to capture the majority. So let's say I want to capture the top, not the top, I'm sorry. I want to capture 99% of all people. So now what we're talking about is I want this to be 99%. Doesn't that mean that this tail and this tail have to add up to 1%? So they would each be 0.5%. Does that make sense? Oh, so this time I want the tail that corresponds to 0.5%. That'd be 0.005. And this, by the way, is going to be a more commonly used number. Because remember when I said I want the cushion, the plus or minus? This is where we would use the cushion, the plus or minus. So let's go to our table. So therefore I want 99.5%. So look up the number that's the closest to 0.995. Well, let's see. I'm looking here and it looks like, oh my goodness, what do you know? They even put a little arrow and an asterisk here for us, didn't they? They're saying this is one of those really important numbers. And what two z-scores is it between? Well, it looks like on my table, it's between 2. Where is it? 3, 4, 5, 6, 7. 2.57 and 2.58. And it turns out it's a computer-generated value. And the universal number that's used is 2.576. We're going one more decimal place because it's roughly halfway in between. By the way, I've had many students say, what if I just take halfway in between? In other words, what if I don't remember and I just take halfway in between? Will I get a wrong answer? If you used a different number for the third decimal place, it's really not going to make much of a difference. But it's computer generated. It's because our tables only go 2 places on the Z. But if I use the computer to ask for more, and by the way, every stats book actually has these printed. Just saying, if you want the most accurate without having to do any work, you don't calculate that number, you're reading it off the table. And now probably the most important, the most common one, because 99% is capturing a lot of people, but aren't I still getting extremes? I mean, isn't that still kind of extreme when I'm out here, or kind of extreme? So the most common when I'm trying to capture is not 99%. We downsize a little bit to 95%. And it's strangely enough, in real life, when we do statistical work, 95% is always kind of the magic number that's used in real life. And I'm talking even in courtroom situations. Courtroom situations are exactly a mirror reflection of what we do in statistics. Believe it or not. When we get to that stuff, I'm going to show you, oh my gosh, the corollaries are so close. So what if now I want to capture 95% of all the values? That means the total in the tails is 5%. That's the total in the tails. So that means each tail is what?
2.5.
2.5%. So now I need the Z that corresponds with a 2.5% tail. And this is our favorite one because this is actually the most friendly one, because look at that. 9750 exactly. I don't have to do a third decimal place. That one shows up perfectly. In fact, if I forget it, I can just look it up. What Z value does that one correspond with?
1.906.
1.96. Just 1.96. Yeah. Now, again, I'm not telling you this. We're reading this from the table. So in some cases, you're going, well, the one I want is between 2 different numbers. So therefore, we let the computer tell us what the third place is. That's actually what's going on here. So on your formula sheet, this is page, I think it's page 2. Am I correct? Or is it page 3? I don't know what page this is. Oh no, it's page, I think it's page 2. On page 2, you see normal distribution, and then it has the common values. Okay. So let me go ahead and,
Oh, okay.
we're going to bring that up. You do not memorize these. Please don't memorize these. So how did I know what they were? Because I've used these for a million years. I've memorized these not because I sat down and memorized them. I memorized them through repetition because I've used them so many times. I know what they are off the top of my head without thinking about them. If you were a statistician and you were actually doing stuff for the next few weeks, let's say you got a job and people wanted you to do stuff, you would know all these numbers by heart because you're going to use them all the time. And the beautiful thing is you never had to calculate them. You just had to know what they were because they came from a computer generated table. That we like that. It saves all the work. Okay. When you use a calculator, you use it so you didn't have to do all that stuff in your head or pencil and paper. And you trust the calculator answer. Well, that's what this is. You're trusting essentially a calculator answer. In this case, a computer answer. All right, so let me show you where this is. Because this is what we're going to use today to help us answer these questions. For today, if you don't, by the way, how many have their formulas with them? You actually, that's probably a good idea to always just have them because, you know, we refer to them and then you don't have to keep writing everything down. All right, so let me bring these up. Probability, there we go, normal distribution right here. See that? Common Z values. That's what we just did. Now, the ones that are halves, the 025 and the 005, those are when we want to exclude both ends. So if I said, I want to know basically what 95% of the people are doing, are thinking, how big they are, what they're eating, because we would say that's the masses, that's the majority. And it's not that you're being somehow, you know, discriminating against the extremes, but no, if I make my conclusions based on the extremes, then I am alienating the general population. I want to make my conclusion, you know, if you're a politician, you're trying to please the masses, not the extremes, I would think. Does that make sense? You know, oh yeah, I want to know what where most people are. Or let's say I make dog food or I make dog products. Wouldn't it be nice to know what the average size of a dog is? And therefore, you know, what is the range of sizes dogs could be? Does anyone here have a large dog? How big is he? Okay, does anybody have a small dog? We had a chow mix and, you know, he lived to be almost.
I had a 27-pound cat.
Our dog lived to be 16. He was about 30 pounds, but he had fur, so he looked much bigger than he was. When you pushed on his fur, he was like this. Now, my dog was, I'd say, a little on the small side. 60 sounds big. My brother has a puppy. He's about a year and a half, but he still thinks he's a puppy. He's 220 pounds right now. So he's a Mastiff, and he's still growing. He's going to get bigger. He'll probably be about 275 pounds when he's done. He moves like a lion. His head is about this big around. When he sees you, if he likes you and lets you pet him, he starts leaning on you. And if you're sitting down, he starts leaning on you and you cannot move. He's a puppy that's over 200 pounds and just wants love. Now, why am I bringing that up? If I'm designing dog products in general, am I designing it for, his name is Clyde, by the way. Am I designing them for Clyde? No, because there aren't a whole lot of 200-pound dogs running around. Clyde has to get special stuff. He has to go to special stores. That guy from the longest yard, he's got to probably do shopping at a Big and Tall. You know, they have places like that specialize in the extremes. But you're not going to go to a Big and Tall store because there's not going to be anything there that would fit you. They're going to be for gigantic people. So when you're designing things in general, I'm saying product manufacturing. You can't get every human being on planet Earth to fit it. You'd have too much stuff, and you'd have a lot of stuff that doesn't sell. I have a heck of a time buying shoes. I have a really hard time buying shoes. I don't buy shoes very often. My shoes do last me pretty much forever. When I buy shoes, I go to the shoe store and I like this kind. I try to find one my size. It is really hard. If I'm buying athletic shoes. I mean, I'm going to a shoe store that sells athletic shoes. Why do you suppose I have such a hard time finding shoes?
Like the average.
No, worse.
Because it is the average.
Because I have a size My feet are 10 and a half, but they're really wide. I call them grape smashers. I would have been great in old Italy. You know, I mean, I'll show you the graph of this. All of my shoes break through right there. There's all gigantic bunions on my big toe. My feet are wide. So I have to wear size 11, which turns out to be the most common shoe size, 10 and a half to 11.
Yeah,
So when I go buy shoes,
they're all gone.
I am the masses, but they're gone because they're the most popular, which is ironic. If I had extremely big or extremely small, really long or really short feet, I'd probably find them because they have them on the shelf and they're just not selling.
And on sale.
It's exactly the opposite, isn't it? So it's kind of funny if you think about it from that point of view. Do not memorize these, have these available. Okay, do you understand? Just have them available. And when I say, okay, which Z value are we going to use as our line in the sand? You're going to say, oh, we're going to use that one. It's actually that simple. Now what we want to do is I'm going to show you how to construct confidence intervals, because this is so powerful. This is one of these things you actually do use in real life. This is something that when you're watching the news or reports are given, this is the mathematics that is used to make these conclusions. People aren't trying to fool you or snow you. People think that you're being lied to constantly. No, not at all. But there is information out there that you can now discern and decipher. That's one of the things I love about stats. Stats you can apply to everyday life. Every time you learn something, and here you go, oh yeah, that explains this thing. So, and again, I go back to opinion polls because most of us are familiar with them. We hear them all the time. We're in April. There's not a whole lot going on. But a couple months ago, there was a recall election. You guys remember that for the governor? Now, regardless of which side of the fence you sat on, leading up to that election, every single day, what were you hearing on the news? Every single day in the week or two before the election, you were hearing how Californians were going to vote, weren't you? But how many of you were asked how you were going to vote? Were any of you asked? I wasn't asked.
No.
But we were told this is how Californians are going to vote. And somebody might get a little bit, bent saying, wait a minute, how can they say that? Because they did their sampling correctly, I would hope. They did their sampling correctly. And based on their sampling, they said, kind of like your free throws, they said, based on what we saw, and we're going to give it a cushion, it looks like this is how Californians are going to vote. Now, by the way, can people change their minds?
Yes. Yeah.
Yes, but assuming nothing crazy and radical happens, people probably are going to vote the way they said they were going to vote. If the day before the election you say, this is how I'm going to vote, something extreme would have to happen for you to change your mind. Do you agree with that?
Yeah.
Has that ever happened in human history?
Yeah.
1988. None of you remember President Hart, do you? President Gary Hart?
What number president was he?
He didn't win the presidency. In 1988, he was the overwhelming favorite of both the Democrats and the Republicans. He was going to win in an absolute landslide. And then a few weeks before the election, Gary Hart was a senator. He was as popular as any politician in my lifetime. Everybody loved this guy. Problem was, this guy loved too many people. He had a reputation as a womanizer, and he was married with family. And the film crews caught him on his yacht waving with, I can't remember the woman's name. I think it was Rice. It was Donna Rice. She was like some famous supermodel. And he's cruising away on his yacht with the supermodel, waving to the cameras. That made it to the news that night. And guess what? President Hart was no more. He dropped out of the election a couple days later. He was going to be arguably one of the biggest landslide winners, maybe of the last century. Weeks before because like I said, he wasn't a good decision maker. Now, here's the irony, is that right before this happened, most Americans were going to vote for him. Republicans and Democrats. He was just that good. Both parties loved him. He was just that good. So he has to drop out of the election. So at the last minute, the Democrats have to throw in Michael Dukakis, who was a nobody, running against the incumbent vice president, George Bush Sr., who had been vice president for 8 years. Nobody wanted him to be president, but now you've got him running against a nobody. Now it was he. So George Bush wins the presidency.
Wow.
But Gary Hart, my point being, opinion polls, they take them every single day, and every day the numbers said overwhelmingly. And you say, well, why would they change? Something drastic usually has to happen. Something drastic happened. In 1992, see, I pay attention because I was teaching statistics. In 1992, Bill Clinton was running for the first time against the incumbent president, George Bush. And it was the first election ever where there was a third party candidate who was actually viable, a man named Ross Perot. He's a billionaire. He was the owner of Ford Motor Company. He was a billionaire. I actually have an old friend who worked for him back in the 80s. Ross Perot was so popular. And by the way, when there's three people running, nobody's going to get more than half the votes. But Ross Perot was so popular that he had a commanding lead. He had a commanding lead over both the incumbent president and the future president. And then days or weeks before the election, in a national interview, Ross Perot was talking about how everyone's picking on him, and he was really getting tired of the aliens and all of the meddling the aliens were doing. He didn't like space aliens. He was talking about the aliens and abductions and all this, and people are watching this going, this guy is completely insane. And so guess what? He didn't win the election. He still, by the way, he still got more than 10% of the vote, but he didn't win the election because people who saw that said, this guy's insane. My friend who worked for him in the 80s said Ross Perot would come by, when he worked, he said, the guy was insane. He was a billionaire, but he was completely off his rocker. So the point being, one day earlier, this guy's in the lead to win presidency. Something happens, and because news is worldwide, people change their mind. That's why, so in case you're wondering, that's why before elections, you hear opinion polls every single day, and it's always the same numbers. You go, why do they keep doing this? Because there's always a possibility that something's going to happen. Now, by the way, it doesn't necessarily have to be a terrible thing, but there's always the possibility that something happens. Maybe two people are running and it's neck and neck, and one of them decides for health reasons, let's say, to drop out of the election, something like that. There are things that take place that can have a drastic effect. O'Shea, you wanted to say something?
Yeah, wasn't there this one president who pretty much like only won one state?
Well, I don't think you could win only one in one state because the electoral.
Like I remember it was quoted. He was like, what, my own state did not fail.
Well, that happens to people running, yes. So if we want to do the whole idea of a confidence interval is I go out and I see something, and we're going to use Rosalind's tremendous free throw shooting skill to start this. We witness something. Does that mean that that is absolutely the probability? In the same way that I'm going to go out and ask 100 people their opinion about a matter, can I now say that applies to 300 million Americans? It's kind of dangerous to have 100 people represented. But if I did it right, and I did, remember stratified sampling? If I said I got the exact percentage of male and female, exact percentage of over 21, under 21, exactly percent, ethnically, if I got this perfect representation, this microcosm of the United States, then the way these 100 people feel, does that make you more trustworthy that is far more representative of the country? If I made sure that sample represented the country? Yes. Is it an absolute match? No, but it's probably the best I could do. Therefore, I'll say, based on this, now let's give it a cushion. Now that from a probability standpoint, it's extremely likely that the truth is in that cushion. You're going to flip a coin to determine if it's fair or not. Well, a coin's 50-50. Oh no, you're not going to, not a regular coin. You've found a denarii, one of those Roman coins, from 2,000 years ago. It's got a picture of Caesar on one side, and I don't know what it has on the other side. It's probably not even perfectly round. It's probably even a little bit warped. You guys ever seen a denarii? I mean, it's not a perfect coin. Do you suppose it's equally likely to land heads and tails? Not a chance. Not a chance. There's nothing about it that would suggest it's equally likely. But you'd like to know which side's more likely. So you flip it 100 times or 500 times or 1,000 times. Would that be a really good way to start figuring out, what if 60% of the time it landed heads? And you did a lot of coin flips. Then do you think it's reasonable to say it's probably around 60% in general?
Yes.
Sure. What if you only flipped it once and it landed heads? Oh, then it's always going to land heads. No, once is not enough. I rolled the dice and I got double sixes. I did it one time. That means my dice are always going to be double sixes. No, I don't think it works that way. I'd have to do it a lot. The whole law of large numbers things. Okay, you guys with me on this? So the mathematics is not complicated. Oh, hold on. And then there's a formula here that I'm going to explain, because this is the one we're going to use today right here. What do we call the probability of success and failure? What letters have we been using? P and Q. Okay. Here's what we want to do. We want to do a confidence interval. We often call it a CI for P, the true probability of success. Problem is, I don't know what the probability of success is. If we're doing an opinion poll, let's keep it simple. It's a yes and no question. I don't care what the question is. It's yes and no. There's not degrees, not opinions. Well, I don't know. Let me rate it a 10 or a 5. No. Yes or no. Do you want it to rain tomorrow? Yes or no? Just keep it simple. Then let's call yes a success and no a failure. Regardless, unless I ask everybody on planet Earth, can I possibly know the true P? No. I flip a coin, unless I flip it, every flip that's, wait a minute, that would be infinite in the flips. I can never know P, but I can do something so many times that I have a pretty good idea. So P is the true probability of success, which I may not know. So what we do is we experiment to find something called P hat. We actually say P hat. P hat is my experimental probability. So when Rosalind shoots 100 free throws and makes 80 out of 100 is the P hat. Another way of thinking about it, P hat is what I observed. And what I observed is the most important thing. When I do my opinion poll, it's what I observed, not what I think is going to happen. What I think is irrelevant. You have to understand that. It doesn't matter what you think is going to happen. It's what actually happened. When I observe something, okay, free throws are an easy one because you either make it or you miss it. Coin flip is easy. It was a tails or it was not a tails. Whatever I observed is the most important thing because that's my starting point. So what is this? Well, this would equal simply the number of successes, which we generally would call X. Successes, okay. Over the number of trials. Rosalind makes 80 free throws out of 100 attempts. That's P hat. That's simple. So P hat doesn't require any understanding. It's just, so Robert went on the beach and asked 1,000 people on the beach, do you like the beach? And guess what he found? He got 997 yeses. The other 3 were people got dragged by their significant other, didn't want to go. Okay, so what's your P hat? 997 out of 1,000. By the way, so he's decided San Diegans, 99.7% of them love the beach. Was this a good sample if he's trying to find out what San Diegans think about the beach? Asking people at the beach.
It's biased.
It's very biased. You guys got the survey? If you haven't physically handed it to me, don't worry about it. Email it directly to Professor Kunyuki because he needs those results by tomorrow because he's trying to solidify the fall schedule. And I told him, I said, you want my students who are physically on campus to respond to a survey about do they want to be on campus online? Could you get more biased than that? What are you guys going to say? No, I want to be completely online. That's why I'm here live. No, of course you want to be here, but it's the sheer numbers. And this is what I was telling all my students yesterday. I said, well, I'm here. Why do I need to say that? There is going to be a class right now hanging in the balance, a class that maybe you want to take. And right now it's in the balance of whether it's going to be online or whether it's going to be live. That's why you have to give your opinion, because what if you don't, but the people who are online who are also giving their opinions, if more of them vote and they say, no, we want it online, now that class that you need might be offered completely online. And that's going to happen in some cases. A class that you wanted, but maybe it was only going to be one class, but more online folks, right? They gave their opinions. Oh, that's why it's so necessary that if you actually care, STEM classes like a chemistry lab or physics lab, those are absolutely going to be on campus. But there are many, many classes that are totally okay online. A lot of you have had classes you go, I don't mind, an English class or a history class. I don't mind it online. It's just information. But others say, no, I got to be live. I can't stand that online thing. And this is where you absolutely have to be selfish. Believe it or not, you have to be selfish because Rosalind, it only matters what is good for you in this situation, not what's good for somebody else. You say, no, I need it to be live. Yeah, I know all those people want it online, but I need it to be live. That's why you have to give your opinion, because if not enough people give their opinions, those who do, that's which way it's going to go in some cases, not all cases. Okay. Imagine the situation is happening right now and it's about this class for next semester. And many more people online spoke, said, no, I want to do this class completely online. So this exact same class that you're in right now, next semester could be completely online because the live folk didn't speak up. That's the point I'm trying to make. It's nobody's doing anything wrong, but this is where you have to look out for yourself. You've got to protect yourself on this one, saying, and if it truly doesn't matter, then it truly doesn't matter, because that's how many have actually filled out the survey? What did it take? 5 minutes? 2 minutes? Yeah, it was easy because it's really completely live, completely online, some hybrid approach. And does it, it does matter what the course is.
But why are they changing it?
Why are they what?
Why are they changing it?
Right now, Miramar is mostly online. Right now, City College is 100% online. We were all supposed to be 100% live. City is still 100% online because they're having a facilities issue. This is what I've been told by some city students, is the buildings themselves are really old and ventilation is not good. And so it's a safety issue. People don't feel, if you were worried about COVID and you were in a room with terrible ventilation and all this, you'd say, you know what, I don't feel totally safe. So City is staying completely online, Miramar is staying mostly online. We were supposed to be mostly live, but right before the start of the semester, 23 math classes got canceled that were supposed to be live because so many people were staying online that now only 42% of the math classes are live this semester. We were shooting for closer to 100%. And so we have the same problem then in the fall. If people want to stay online, we're going to offer, we want to be live again. And there's going to be some online because certain courses are fine online. But most of the courses we know should be live, but we can't make people who are online, we can't make them change. It's sort of, we're gonna service as many people as we can.
We're not making them change, but then if they go online, it's forcing us to change.
Yeah, well, that's why you got to
Our
speak up.
voice matters.
Yeah, that's it. This is no way political. You're not voting for something. You're saying, what is the best for me? And it really just comes out of online, live. I kind of wish we were 90% live and leave some classes online that can be done online effectively, because we had a few online courses and most of them were stats, by the way. Before the pandemic, almost all of our online courses were stats, and they were asynchronous online. And I know the teachers, they developed the courses. My youngest daughter took that course, 100% online.
It's hard.
And yeah, it was really hard because the inability to ask questions and things like that.
That's why I'm here now.
Yeah, but a lot of people like the convenience.
Yeah.
That's really what it comes down to. So here's the situation. We're going to do this. Now, the plus or minus, it's called the error. When you are watching the news and they give you the results of an opinion poll, every time on the bottom of the screen, it will say, they usually don't say it out loud. Sometimes they do. They'll say, and this poll comes with an error of plus or minus 3%. Again, why? Because they didn't ask you. They did a really good job of getting a really representative sample, but they still only asked 1,000 people out of 300 million people. So there's going to be a cushion. How do you calculate the cushion? This is the cushion right here. Now it's kind of hard to see. That's small. So I'm going to leave that up for a moment. Alpha is equal to what we call the tail probability. Alpha is a Greek letter, like mu and sigma and all those guys. We love Greek letters in stats. It's alpha. You guys will. So you're told what the tail probability. So if I want 95% of the outcomes, then the tail probability is 5%. If I want 99% of the outcomes, then the tail probability is 1%. Does that make sense? The tail probability. But when I'm doing this and I want the masses, then that means that each tail is half, right? So when we said a 5%, we had 2.5% in each tail. When we said 1%, 0.5% in each tail. That's why it's hard to tell. This says alpha over 2. That's what that is. Hard to, at a distance, it's hard to read. But if you look at your sheet, you go, oh, that's what that is. That's alpha over 2.
Okay.
So if I want a 95% confidence interval, then alpha is 0.05. So alpha over 2 is 0.025. Oh, and then I would use that special Z value that we just looked up. That's the order of things. So what we do is we take This number is given, that's a fixed number, I look it up. P hat, I measure it. Successes divided by trials. What's Q hat? Well, 1 minus, it's what's left. So if Rosalind makes 80% of her free throws, then she must miss 20%. Why? Because it's got to add up to 1. So P hat, you measure, Q hat's what's left. N is the number of trials that you already know that. And then this number you look up. This is my error, and you write it as a decimal, not as a percent. And that's the plus or minus. So let's do an example of this because it's actually really cool. And there's so many things I can do with this. All right. So Rosalind made 80 of 100 free throws. You know, she had a cold and she was sneezing, and that's why she missed a few. Otherwise, she would have made 90%, right? Now, we want to construct, here's how we write it, a 95% confidence interval for the true probability P. What is my measured P? Well, it's 80 out of 100. But like we said before, does that mean Rosalind will always make 80%? No matter if she shot 10,000, will she make exactly 80%? Well, 80% is a really good starting point, wouldn't you agree? And I think it's even safer to say, no matter what we get, it's probably going to be close to 80%, because it's unreasonable to say, well, no, she's a lifetime 50% shooter, but she just happened to make 80 out of 100. Or she's a lifetime, she's actually never missed until today, you know. To say she made 80 out of 100, that's a good starting point. Her true lifetime probability is going to be a plus or minus. I asked 100 people nationally a question and 80% said yes. Same thing. Then what do I expect the actual population to say? Well, it'd be a plus or minus. There's no difference. So what do we have to do? So for a 95% confidence interval, that means 5% tails or 2.5% in each tail. So the Z that I'm going to use, 0.025 is half of 0.05 or half of 5%. That's the 1.96 on your sheet. It's right. Oh, it's right here. And by the way, I wrote 1.960 just so all of these were 3 decimal places, but you can use 1.96. It's not, you know. By the way, computer generated, it's still 1.960. You guys don't have to do that. In a regular 119 course where they're maybe working with the computers every day, they wouldn't look these up. They would keep calculate. They'd have the computer keep calculating them. And if you were a student, at some point you'd say, we keep using the same numbers over and over again. Why don't we just write them down? Why do we have to keep having the computer calculating them every time? That's why I say these are kind of like the magic numbers. These are the only numbers ever used in real life. I mean, yeah, you could do other numbers. I want the top 3.5%. I want to take the top 17% of the population. Yeah, probably not. You know, usually say 1%, 5%. So what do I know? What's my P hat? It's 80 out of 100. And by the way, I'll just leave it as 80 out of 100. What's my Q hat then? Well, how many did she miss? 20 out of 100. But it's out of 100 because it's got to be a probability. Oh, because 8 out of 10, 80 out of 100, 800 out of 1,000 is the same probability, but the N is part of the equation, isn't it? That N is huge. So in this problem here, let me write it down again. P hat is 80 out of 100, and you can certainly say 0.8. Q hat is 20 out of 100, so I can certainly say 0.2. N is 100, and my magic number, my magic Z is 1.96. That's all the numbers I need. So the error, the cushion, the plus or minus, it's called. Now, why do we say error? Well, because do I know I'm exactly right? Again, going back to the opinion poll, what does it always say? This poll comes with an error of plus or minus. They're saying because we don't know that we're exactly right, but we suspect we're really close. We know we're in a range of values. So the error is 1.96 times the square root of 0.8, 0.2 over 100. Now, that's simple to write. Now we need to calculate it. And this is where we sometimes get in trouble because parentheses may be required here. So let's all do this together. So when you're entering this, you want to do it like this. 196 times. Now, get your square root button. You've got to enter 3 numbers and all 3 of them have to be inside the square root. You will have to use parentheses. Okay? So start with 196 times, hit your square root button, and then open parentheses. Now the parentheses are to tell the calculator what numbers you actually want inside the square root. If I don't use parentheses, I will only be taking the square root of the first number. Now, some of your calculators will keep it inside the square root automatically. How many have a calculator where you actually have to use the arrow key to get things out? Does anybody have one of those kind of calculators? No, you need the parentheses. Some of you have the calculators where you have to use the arrows because everything stays in unless you do the arrows.
Yeah.
Does yours have arrows that you have to use? So you do have the arrows, probably, don't you? Okay, can you work with him for a second since you have the same model? This is not hard, but we want to make sure that we're entering it correctly. And then I just go 0.8 times 0.2 divided by 100 and then close. Okay. It should be a really small, we got it. It should be a really small decimal. 0.8 times 0.2 divided by 100.
I'm right here, so.
Oh, now divided by 100.
Just divide it.
Divide by 100.
Okay.
Yeah, and then
Now, here we
go
go.
back to.
You said 7. It's 0.07. That's not the
I
same.
did something wrong.
Oh, you forgot to divide it by 100.
No, I
Sorry.
didn't.
0.074.
I got that too.
Square root of 0.8 times 0.2 divided by 100. Did you multiply by 1.96? No, you multiplied by 100. That's right. Yeah, your answer is too big because of the decimal. Okay, what did everybody get?
0.074.
Does everybody get 0.0784?
Yes.
Excellent. Which is, by the way, almost 8%. That's your cushion. So here's how we answer the question. I'm gonna leave this up for you. So what we say is we really write it like this. We believe that P is between P hat plus the cushion and P hat minus the cushion. That's what plus or minus means. I'm going to add it and I'm going to subtract it. What are we adding and subtracting it to? For 80 out of 100 or 0.80. So that means that this was 0.8 plus, and I want to use all the decimals. There's no reason to lop anything off. And this would be 0.8 minus. So use your calculator. What would this be? Sorry, that was 0. So this would be what? 7216. And this would be 8784. I think that's what we would get. Now, Rosalind shot 100 free throws. She made 80. With 95% certainty. This is the language we use. Why? Because it's called a 95% confidence interval, because we said, here's an easy way to think about it. Is it possible that Rosalind shoots way over 90% in general? Is it possible that Rosalind shoots only 50% in general? This was just a really good day. Yes, but those results are so extreme, we don't want to include them, kind of like our clothing store. I don't need to include the tallest and shortest person on planet Earth when I'm developing my clothing line. So we're saying of all the possible outcomes that could even occur, we've captured 95% of them. The middle 95, we're excluding the most extremes. So we're saying this is the real range of her free throw shooting skill. Now, what if you said, Rosalind's like, I'm not happy with that. It's too big of an interval. My high to low is too far apart. I would like that to be a much smaller range. Does that mean she should have made more free throws? No, has nothing to do with it. What's the only way I can, by the way, you chose this number. These were measured numbers. What's the only thing you have total control over? The number of trials.
Okay.
Look in the formula. Where do the number of trials go? In the denominator. How do I make this number smaller? By making the number of trials bigger. Oh, so when we talk about things like opinion polls and stuff, how do I make my error smaller? By making the sample size bigger. That's the only thing you have total control over, by the way. Right, so if Rosalind only had time to shoot 3 free throws, our confidence interval is going to be really wide. But let's say you had time to shoot 1,000 free throws. Okay, so we're going to change the problem now. Rosalind is going to shoot 1,000 free throws, and you know what's really crazy? She's going to make 800 out of 1,000. Boy, that 80% is looking pretty good, isn't it? And she's going to now miss what? 200 out of 1,000. But now my N is 1,000. So what changes over here? Only that. So let's do that calculation, folks. Rosalind's now going to shoot 1,000 free throws and make 800. That's a huge, huge sample size. And her arms are really tired. Actually, part of the reason she missed so many, she was shooting left-handed for a while because she was giving her right arm a break.
Yes.
Right? Remember how we said probabilities, we use the 4 decimals? That's kind of universal. We'll stick with that here, just for consistency's sake. And the reason we often go 4 is the Z tables are all 4 decimal places, probabilities. Now, did this number change?
Yeah.
Hugely.
Yeah.
To 4 places, now what do you have?
0.0247
Go ahead.
0.02479.
So 479, I'd round it to 48. That's much smaller. My cushion now is way smaller. I'm only doing a plus or minus of a little over 2%. That plus or minus was almost 8%. Okay. Does that make sense? Okay. If we could keep increasing the sample size, what's happening to our cushion? It would get smaller and smaller and smaller. So Rosalind says, I'm going to go out and shoot infinity free throws. I want to be, well, that's probably not reasonable, right? It would take at least till afternoon. So everybody kind of get what's going on here? Now, let's say,
Professor,
yes,
really quickly, what I don't understand is, so will that be the answer, or I don't understand?
that's the error. So now what we would do
Oh, that's
is,
the error. Okay,
that's
okay.
the error. So now what we're going to do with this problem,
That's the part I don't understand over here.
248.
Okay.
So what did that do? What did that do to our interval? It made our interval much smaller. And by the way, when you're talking about confidence intervals, when you're talking about pluses and minuses in general, you would really like it to be small, wouldn't you? You'd say, I'm in this range of things. You know, it'd be like saying, well, you know, next year, my company has been doing really well, and we did some statistical analysis. And next year, our company is we expect our company to make $5 million plus or minus 10 million. And by the way, I see reports like this. I get prospectus, you know, because kids have investments in retirements and school funds. We'll see things like 5 million plus or minus 10 million. You do realize what that means. We could make as much as 15 million or lose as much as 5 million. Are you happy with that big of a range? We're going to make $5 million plus or minus 10 million.
No.
That's kind of a ridiculous range. Wouldn't you rather say 5 million plus or minus, you know, 100,000? I'd like the plus or minus to be really small compared to what I'm looking at. If the plus or minus is huge compared to what I'm looking at, then it's not very useful. We found that the average height of a Mesa College student is about 143 centimeters, plus or minus 100 centimeters. That means you're like 7.5 feet tall to like 1.5 feet tall, I'd be really accurate. That's probably true. I probably got almost all the Mesa College students are between 1.5 feet and 7.5 feet tall. Is that range a little too big to be useful? Yeah. My point is, the only way you can control the cushion, the error, is with a large sample. The smaller n is, then the bigger the error is. So in this case here, we didn't change Rosalind's observed free throw percentage. What we changed was the number of attempts, and that made this cushion so much smaller. Do you notice from high to low is less than 5% from high to low? It's only about 2.5% in each direction. That is reasonable. Anytime you're doing a percent error, you're doing a cushion, 2 or 3% is considered a really small cushion. That's why opinion polls, you always see those kind of numbers because they take really big samples. So let's do an opinion poll thing. So, and we'll keep it simple. We'll say it's Mesa College. So at Mesa College, you want to find out the percentage of students who, let's do something simple, who take public transportation. To get to school. Okay, so you basically are going to sample. The nice thing about this type of sampling, do you have to ask somebody in person, or could you even do it through an email? There's a lot of ways you could do the sampling, but you want to ask a lot of people. And so the question is, do you take public transportation to get to school? Yes or no? It's real simple. If let's say you get a ride every day from your sibling or your parents or something, but one day you had to take the bus, do you take public transportation to get to school? No, you get a ride from somebody else. No, I'm talking about somebody who takes the bus every day or takes the trolley every day. So you're asking somebody a simple question: do you take public transportation to get to school? So it's a yes or no question. It's not a maybe. It's not. I'm not going to answer. And by the way, you don't count it. So you're trying to get a feel. Now, does this cost money to ask this poll? No. Does it take a ridiculous amount of time to ask this poll? In fact, is this poll time sensitive in any way? Elections are time sensitive. Remember Gary Hart, depending what day you ask the question. The day before the scandal, you were voting for him. The day after the scandal, well, you might still be voting for him, but you probably weren't. The day before Ross Perot, complained about the aliens interfering with his daily life, you might have been voting for him. The day after, you probably weren't. So the point is, political polls are often time sensitive. I'm asking a question about public transportation. Does it even matter when I ask you the question? During this? No. So you can make the sample really large. It doesn't cost any money, and it isn't terribly time sensitive. So there's no reason to make this a small sample. So let's suppose you were able to ask, well, there's a weird number, 984 people, and 167 said yes. Do you take public transportation? They said yes. I'm just making up the numbers. I have absolutely no idea. This is how polls work. You are pretty confident. You are pretty confident that you did a good random sample. See, I'm going to find out what percentage of Mesa College students take public transportation. So I'm going to wait at the bus stop at Mesa College and ask everybody who gets off the bus at Mesa College. Well, then wouldn't it be 100% say, yes, I take public transportation because I'm only asking people who got off the bus? You realize that's ridiculous. I'm going to go to the parking lot and station myself in the parking lot and ask people as they're getting out of cars, Do you take public transportation? No, now your percentage is going to be 0 because they drove to school. You do understand how to avoid a biased sample. Don't stand at the bus stop or don't stand in the parking lot. No, ask people. By the way, this is a perfect example. I have absolutely no idea how you guys got to school. So if I asked you guys, do you take public transportation? I have no idea. I already know the answer by stand at the bus stop or by stand in the parking lot.
I saw you.
If you're getting out of a car, you're not taking public transportation. If you're getting off the bus, you are taking public transportation. So the idea is you conducted a good random sample. Heck, maybe you got an email list and you were able to email people. There's a bazillion ways you could do this accurately. So this is what you measure. So first off, what is our hold on a second. Okay. So we want, again, a 95% confidence interval. So we're going to use the same Z. Okay. What is our p hat? It's going to be 167 over 984. We asked 984 people, 167 said yes. What's our q hat? Well, I don't have to calculate, but the denominator is still 984. How many no's do I have? Well, it would be 984 minus 167. So what is that?
Can you repeat what you just said?
How many no's do I have?
817.
817?
Yeah.
Okay, because those kind of have to add up to 1, no? Do I have everything necessary to calculate my error?
Yes.
Yes. So once again, the Z we're going to use is the 1.96, just like in the last example. And again, like I said earlier, that's the most common one used. And I'll explain when you would want to change. So our error is 1.96 times the square root. And here's the nice thing, I have a calculator. Just use these two numbers. You don't need to calculate them first and then enter those decimals. Just use these two numbers exactly as is. Yes, Robert.
Is the 1.96 like a universal thing?
Well, that was the first 30 minutes of class today. Yeah. Yeah, that was kind of important. That's what we spent the first literally 30 minutes on that stuff. So 167 over 984 times, would you say 817? I chose numbers that were not necessarily friendly to show you. I don't have to calculate the p hat and the q hat. I just have to enter them into my calculator. Over 984, that's still. Now you're gonna need parentheses, lots of parentheses.
Yeah.
And so this is the tricky part. That is the answer. And that has to be done with a calculator. But now it's on me to enter it correctly.
Yeah.
I'm gonna show you a trick. The problem a lot of us have is the whole parentheses thing. We don't know how to do it. There's a way of doing this. Your calculators can do this. If you calculate the part inside the square root first and then hit square root answer, you can do the whole thing without any parentheses. If I do square root first and then parentheses to tell the calculator what's inside. So literally, if I do this, 167 divided by 984 times 817 divided by 984, and then take all that divided by 984 and then hit equals, that gives me what's inside the square root. Agreed? I don't need to re-enter it. Now I can go square root answer. You have a key on your calculator that takes the previous value, like whatever's on your screen. And now you can say times 1.96. I'm showing you a way, if you really hate the parentheses, I'm showing you a way to do this without ever using parentheses. Or you go square root and use lots of parentheses. That's absolutely correct.
Add the answer. Hopefully.
Let's all do it to make sure we all get the same thing. And what do you have, Russell?
0.02345.
Perfect. Isn't it nice to know that you hit the right buttons?
Yes.
Okay, so that's, we get, this is approximately, and again, we're rounding it off, but we'll go 4 places. 023. Now, is it 0234 or is it 0235?
235.
I round up because the next number is more than halfway. So 0235. By the way, if you make a mistake in that 4th decimal place, will that have earth-shattering consequences? Probably not. If I make a mistake in the 1st decimal place, yeah. Probably not the 4th decimal place. So my confidence interval. The true value of P is between 167 over 984 plus this, which we're going to calculate this as a decimal in a moment, and 167 over 984 minus this. Now, that doesn't help me because I have a fraction plus a decimal. Do you agree that's not entirely useful? So take that whole thing and make it a decimal now. It's more useful to me to have decimals in this case because those are probabilities. But you see how I at no point did I ever actually calculate this and write it down. I didn't need to. I needed to use this value. Now I'm calculating it. So we went out and constructed a proper sample. When I say a proper sample, I mean a non-biased sample. And we went out and we asked 984 people, and 167 said yes, they use public transportation. So if I want to reflect the true population, remember Mesa College, most years we get up to 30,000 students. We asked 984. We didn't ask 30,000. So I don't know the exact number, but I know a cushion. So we can say the actual probability that somebody uses, or if you think of in terms of percent, somewhere between 14 and 19%. You see how that's useful? And that error was only a little over 2%, 0.02. So that means I feel pretty good about whatever this is. Now, why, just the situation, you said, I just want to know, why would that matter? Well, actually, this is huge. Because if you're taking public transportation, then you're not driving a car. Would that matter? How many here drive to school? What's your number one issue? Starts with a P. No, the P word. Parking. Yeah, anybody ever been to San Diego State? Oh my God, it's the worst parking on planet Earth.
I've disabled parking, so. No.
But the point is,
Yeah.
how do we possibly decide how many parking spaces to make available, or whether we need more parking unless we know how many people are actually
That's true.
driving? Oh, see, if you're taking public transportation, you are the friend of Mesa College because you're not driving on the campus. You're not taking parking spaces. There's nothing. You're not causing traffic and congestion. You actually are looked upon very highly because you're not causing. The rest of us who drive, like myself, who drive one human being in the car,
Yeah,
we are the problem, aren't we?
you're the problem.
See, unless you're carpooling, you are the problem, aren't you? Oh, yeah, because one car per person, you're talking tens of thousands of cars. That's, by the way, that's why this kind of information is really important, because it has everything to do with parking. Yeah, you see where I'm going with that?
Yeah.
All right, let's take a short break. We've been going for almost an hour and a half now without a break. Is the mathematics hard to do? No, it's calculator intensive, but
Yeah.
I'm entering numbers in my calculator. Yeah, that's, once I get the hang of that, that's easy. But we're going to do some more problems. And then the next thing we're going to look at is, okay, so let's say there's an issue coming up. And by the way, are there ever issues where it's really close? I mean, you don't know which way the population is going. It could be a national election, could be a local thing. It could be there's something on the ballot that's very controversial. You know, like anything related to taxes is always very controversial, but maybe there's something on the ballot and it's one of these, it could go either way. It's really, really close. But you want to be able to see, news agencies love taking the credit. They love to say, we called that election, or we got our news out there. I watch sports almost exclusively, and it's really funny. It's who has the breaking story. You know, when Tom Brady announced that he unretired, that was the big news. But the second biggest news is which reporter broke the story. Do you understand that you get all of the credit, or which network first broke the story? That's huge. That's the only thing that networks care about. They don't care about what the story is. They care about who was the first. So when it comes to things like elections and political stuff, it's who broke the story first, who actually called it accurately first, because then we give them a lot of credit for, hey, you guys are on. We trust you now more than we trust other people because you called it early and you got it right. And so that's the kind of thing. So if something's really close, you can't have, I don't remember which election it was, because I always pay attention to that kind of stuff. And it was really funny. It was not a recent one. It was a few presidents ago. But they said, right now, one of them's ahead, 48% to 47% or something like that, with a plus or minus 12%. Now, think about that for a moment. So I was saying, you're going to get 49% of the vote plus or minus 12. So if you get 61%, then you won in one of the biggest landslides in history. But if it was the 12 the other way, then you got 37%. You lost in one of the biggest landslides in history. So in other words, it's too close to call with an error. Plus or minus 12% means it's either going to be neck and neck or it's going to be an absolute landslide, but we don't know which way. That's terrible reporting. That's terrible statistics. You can't say it's neck and neck and the error is astronomical.
Yeah.
That means they did a terrible job because you have absolute control over the size of the error because it all depends on sample size. So I'm going to show you guys how to fix the error before you even do the poll. In other words, how many people do I need to ask? I can work backwards and say, how big does N have to be? Now, remember the two issues, time and money. Opinion polls don't cost money, but often they're time sensitive. Like we said, if it's an election, it's probably time sensitive. I can't wait till 3 months after the election to collect my data. I kind of have to do it now if I want to get the information out there. If the election's next week, I kind of need the information out there right now. So elections tend to be time sensitive. If it's an opinion poll about student life on campus, I got all semester to collect my data. But on opinion polls for elections, you actually have a very short window. Agreed? Because you can't do it after the election. Well, who cares? So I have a short window. Therefore, the sample size, I want the biggest samples I can possibly get, but I may be limited because I don't have enough time. So we're going to actually do the calculation. Let's take a break. We'll do the calculation of how to do the sample size.
Everything I don't understand. How would you put the fraction of 9?
Oh, just that divided by? No, the problem is, are you still inside the square root? Yes, you are. Yes, you are still inside. Your calculator is leaving you inside the square root. So go ahead and go divided by. No, inside the square root. Go ahead and do divided by. Because I'm looking at the bar. Divide by 984. And that hit equals.
Oh, okay, I see.
All right. Gentlemen, on the last quiz. You guys turn in Andrea's quiz. Without any work. She turned in work on a separate page. Okay, can't do that. You had answers without any work that are even possible for any human being to calculate. You had probabilities involving z-scores without calculating a z-score. Okay. Not doing the work for me, but don't take somebody else's work. That was not really difficult from that standpoint. And it was verbatim. You even put arrows instead of equal signs because that's what she put. Nobody uses an arrow for equal signs. So you weren't very discriminating, which worries me. There's only 5 lectures on the next test, and that was one of the more important ones. And blew it off over vacation. I get that, but take your lumps because you can always do it later. Remember, but and you still need to do that because that's probably half the stuff we're doing on this next test is, you know, given outcomes, what's the probability of looking it up? So make sure that you get to that.
Oh, I'm sorry.
Why so worry about you or you?
Yeah, I still haven't gotten my education done because, yeah.
Okay, but anyway, overall though, this is still we doing day to day.
Yeah, I'm really tired most of the time. I can't like keep
But if
food
it's
down.
time doesn't work.
No, I can't have food down anymore.
Oh,
I'm
wow.
not really eating like even water like this.
What's going on?
I don't know, so every single time I eat anything or even drink water, no, it makes me feel like I don't know why, like even water. So my body.
Is there something like an antacid or something?
No, it's gonna be like, so my pancreas has a cyst on it, so for whatever reason, things aren't digesting the way they're supposed to, which worries me that the cyst may not be benign and it could be cancerous. So I'm
Like I
just
lean towards one idea and then like.
Well, that's nice to have a addressing the problem.
I'm leaning on like.
Yeah, not thinking about it is
If I
not gonna
stay
make it go
here,
away. I think we need to address it. Do you have a team of medical professionals that you can trust, or do you just keep shifting from one doctor to another?
I have a set doctor that I have, but he's not the one that does my.
I'm pretty sure my
mental health.
Well, the CT isn't the doctor, that's a technician who just does it, and then somebody else reads. It's like an X-ray. Somebody does X-rays, some doctor reads the X-ray.
I go to script screen, so.
But is that what my heart?
Is that the La Jolla one?
Yeah, that's what I'm talking about.
That's,
Yeah, that's true.
some of my kids were born with that.
Yeah.
I think the first few. Actually, I'm not sure. I know that I've been there for more than one.
But I
I
haven't.
might have been like 3. I liked that hospital. I think, well, for babies and stuff. I don't think I had any reason to go there for anything else. But now I can't remember what other hospitals are they going to? I think we probably have one at Sharp. What am I looking at? Who's this?
My friend works at animal hospital, so sometimes she sends me.
How
videos.
small is that dog?
I don't know, but how cute is
The person's
that?
hand was bigger than his tail. Yeah, this reminds me of, you see the commercials for like SPCA.
No,
And then you have the
Sarah
female 90s singer.
that's
who-
Sarah
Sarah
McLachlan.
McLachlan, who, and then you watch it, and if you're not crying, it means you have no heart or soul.
That's
And
true.
then you're like, I'm gonna get the money, I don't even know why.
I know.
Those are so devious, those commercials.
A 19.
You guys know what I'm talking about. Okay,
Yeah.
Sarah McLachlan
Yeah.
singing automatically makes you tear up. I
Just
can't watch-
hear it.
She sings in one of the Toy Story movies and everybody cries. You know?
Yeah.
You remember that scene when, you know?
All she's gotta do is sing.
But then they show the cute puppies that these puppies.
That's a
are
long
literally
commercial.
destroyed.
Yeah.
That's a long commercial.
Like, oh my God, talk about tugging at your heartstrings.
Sad music.
And if you feel nothing from that commercial, seriously, you have no heart. You guys know exactly what I'm talking about,
Yeah.
right? 5 cents per minute.
You should be ashamed you bought that coffee. They make you feel terrible.
I should probably stop recording here. This is an obvious question, and Junior asked the question, Rosalind asked the question. When would you use the other ones? If I have a situation where we said I want 95% confidence interval. If this is medical and I'm doing, let's say, cancer research, or I'm trying to do screening and I can't really afford any errors. I'm doing some form of cancer screening with a blood test. I want a larger confidence interval. I want to include more things because I don't want the possibility that you gave a blood test and let's say I did a weak test. I just did a really quick screening and nothing showed up, but you actually had cancer, which by the way, will always show up in a blood test. You would say, no, I want that to be much stronger. I want to capture more possibilities. So a 99% confidence interval would be a situation where I need to capture more. I know I'm going to have a greater cushion, but I want to make sure somebody doesn't sneak under, especially if I'm screening for something bad. Does that make sense? And so it's that kind of thing. In a court of law, I don't want to find somebody guilty if they're really not guilty because I made it too easy. I want to make it really hard. So I'm going to have a larger confidence interval to force, so only the extremes will be the guilt. Does that make some sense? There are situations where you say, no, I need it to be bigger because I can't afford that error.
Yeah.
And medical is one of them. They tend to have larger confidence intervals because, again, if you had the cancer, we want it to show up. If I make the confidence interval too small, you might be just outside of it. You know, there are situations. Let me just put it that way. But the most common, if it really isn't a life and death situation, the most common is the 95%. And the reason is, the larger the confidence interval, the bigger the cushion. And sometimes in real life, you don't want a huge cushion because there's too much variability. I use the example of, a company making $5 million plus or minus 10 million. I've actually seen that. The election where it was too close to call plus or minus 12%. That's absurd. That's just really, why even bother telling people at that point? you just sound like a knucklehead. It'd be like saying, how do you think you're going to do on your next test? Rob said, I think I'm going to get around 80%, plus or minus 50%. Does that sound completely absurd? 80% plus or minus 50? By the way, and you're almost certainly going to fall in that range, won't you?
Yeah.
Between 30% and 130%? Yeah, I think it's probably safe, but that's not useful. So what if I said, I want to do it, and this is usually for opinion polls and that kind of thing. I want to make sure my error is small. Now, you can't have the error be 0 unless you ask 100% of the population, and that's just not realistic. And the free throw shooting, I can't have the error be 0 unless I have you shoot all the free throws you're ever going to shoot, and then you never shoot another one. In other words, I have all of the free throws now. That's not realistic if it's even possible. So now we say, what if I want to control the size of the N? Okay. We're now going to kind of work backwards. Okay. What was error equal to again? It was the Z, and we called it the alpha over 2. So in this case, it was 1.96. It was the 2.5% tail. It's whatever Z you looked up. This is a constant. You don't calculate this. Times the square root of P hat times Q hat over N. Using a little bit of algebra, I want to write M equals. This is the formula we've been using for the last hour.
Yeah,
You're saying
but
that
don't
last
say
one?
algebra. When you say the word algebra, my brain
That's
says
why I put your algebra.
Everything you've ever done in your life involved a number with algebra.
I don't like that word.
You go to the bank and deposit money, that's algebra. Now, arithmetic is just the adding and subtracting of numbers, but it's all included. I need to write N equals. Where does, well, so right now, that's a coefficient. So can I write E divided by Z? Can I do that?
Yeah.
Okay, so let's do that. What's the only way to undo a square root?
Square.
Square it. Perfect. That's the exact answer I wanted to hear. To get the N out of a square root, I gotta have to square both sides. What happens when you square a square root?
Squares.
It goes away. Right? You squared the square root. There's no more square root. So what have I got now? I've got E squared over Z squared equals P hat Q hat over N.
So many letters.
Yeah, but no, they're all known. We know all these values. That's the thing. So let's do this.
It doesn't say that on the.
Well, no, that's the finished. I'm getting you there.
Oh, okay.
I'm getting you there. I'm showing where it came from.
Okay.
So now let's flip them both over because I want the N on top. So if I said this, if 1 over A equals 1 over B, then isn't it true that A equals B?
Yes.
I'm going to take the reciprocal of both of them at the same time, because otherwise it gets too icky. So I only need that. So I'm going to erase this for a moment. We're trying to get the result. You're never going to do this again. So if I flip them over, now I got the Z on top. And then the N. Oh, now I can just multiply both sides by this. Move it to the other side. Everybody understand? Multiply both sides. And now I have my n. P hat, q hat, the z squared over the e squared. So the n is going to be, so what order did I write here? I wrote the z first. Okay.
Did you start recording anything?
Yes. So I've got the z squared. I look that number up. I don't calculate it. P hat measured.
Yes.
Q hat measured over this. Now, you said, but I don't know what the error is. No. You are determining the error. You're saying, I want my error to be no more than 2%, 3%, 5%. If you've decided I want the error to be no more than this. Now, I don't know that it's a law or industry standard, but I pretty much can say every opinion poll I've ever seen, they always say the error is plus or minus 30%. That's kind of the magic number in opinion polls. Okay, meaning they chose the error ahead of time, then they sampled enough people. That's how it works. The reason this is an inequality is I say I ask that many or more, I just can't ask less. Okay, so if I want my error to be no more than 3%, it means I have to ask at least this many people. That's what in words. I want my error to be no more than this, I will ask at least this many people. Is it okay to ask more people? Sure, I just don't want to ask less people. So the way we work that, and we're going to do this, we want to ask an opinion. Now, there's two things going on here. The P hat and Q hat are kind of odd in a sense, because I'm going to go out. Last week I asked an opinion poll, and the week before I asked an opinion poll, and the week before, every week. This is typical leading up to elections, right? We're going to ask opinion polls every week. Do the numbers drastically change on a weekly basis? Probably not. So what I'm going to do is use last week's numbers when I do P and Q to help me figure out how big my N should be. You've never actually started the opinion poll. You haven't actually asked a single person a question yet. You want to conduct an opinion poll. You want to find out the most important question of all. How many Mesa College students have dogs? You don't have no idea. So you're going to want to find out what's the probability a Mesa College student has a dog. You don't have a P hat and a Q hat. So what should you use if you don't have any idea? You use 0.5 for each. If you have no idea, you start by just using 0.5 for each. Because doesn't there have to be a first opinion poll? Doesn't there have to be a first question? So they, more often than not, the beauty of this is more often than not, you're going to use 1/2 for each one. So I'm going to put this, if you don't know, if you have absolutely no idea what P hat and Q hat are, because you've never actually asked the question, then you use 1/2 for both. And what ends up happening? It's 1/2 times 1/2, which is 1/4. And you notice in the formula that I put the 4 in the bottom. You like this one because this is ridiculously short and sweet and easy. And in real life, that's the one you're usually going to use. The only reason you would have a previous P hat and Q hat is because you've done this before. Okay, and I'll give you a simple example, because the last thing that I can remember that we voted on was the recall election. Again, I'm as apolitical as you can get. We had a presidential election, I know, in the last 10 years. I just don't remember much about it. I don't really even care. I like the mathematics of elections. I don't really care about the elections themselves. But we had a recall election. And I would say for the 3 months leading up to the election, if not every day, certainly every couple of days, we were told, here's how Californians are going to do it. And by the way, those numbers didn't change much from day to day. Therefore, they used those numbers to figure out how big a sample. But there had to be a first opinion poll. And Rosalind wouldn't say, oh, I'm going to do an opinion poll. I think 90% of the people feel this way without having any idea. Because I have a couple of friends and they feel this way. No, that would be not wise. You'd probably say, I have no idea, so I will start with this one. Now, if it was extreme in one direction or the other, then I will use those numbers in the future. And that would be wise too.
Where did the 4 come from?
I just explained it like 3 times. 1/2 times 1/2 is 1/4.
That's where that four came from?
You have 1/4 on the top, which means you put the 4 on the bottom. Yeah.
Okay.
Yeah. So realistically, except in certain situations, see, the first one is a formal thing, but the second one is a more practical thing. And by the way, the Z is one of our magic numbers, and the E you determine. Okay, so let's go back to Rosalind's free throw shooting. We're going to ask how many free throws do we need to shoot? We're going to narrow down our interval. Are we going to use 1/2 for Rosalind's free throw shooting, or the fact that we've seen her shoot 10 billion free throws and she's made 80% of them? What number should we use? 1/2 or 0.8 and 0.2? 0.2. We have prior information. That's an easy one. We've seen her shoot free throws. If we never saw Rosalind shoot a single free throw, then we'd use 1/2. But we already seen it. So how many? Rosalind's going to get very tired, you know. That's why I say you want to get ambidextrous, you know. So it's just, you know, like tennis players, you're going to have this one overdeveloped arm.
Right.
You ever watch tennis players? Tennis players are hysterical. The right-handed player versus, they will have one overdeveloped forearm and biceps. And in college, I had a friend who he was a huge tennis fan. And there was this one particular tennis player, a guy named Guillermo Villas. He was a great tennis player. And this guy looked like a bodybuilder. He'd stand there like he had a poster of him standing like this. You see this huge arm. But if you turn the other way, this seems like a spaghetti noodle on the other side. It is so absurd.
Well, I mean, I've done tennis practice before, like when I was younger, and it's like you constantly practice, like you're constantly throwing it and then hitting it in the
Yeah, you work one arm. It's like doing one arm push-ups all day long, but always on the same arm. It's kind of funny. So Rosalind's gonna have the one overdeveloped arm because we're gonna make her shoot about 1 million free throws.
And a spaghetti noodle.
And the other noodle, yeah. How many free throws must Rosalind shoot? By the way, the number of free throws she shoots, that's the number of trials. That's the sample size. So we have to realize, oh, that's my M. That's the thing we have total control over. How many free throws must she shoot to have an error of at most 2%? Remember how we did a confidence interval earlier when she shot 1,000 free throws? Her error was around 2.5%. Is she gonna have to shoot more than 1,000 or less than 1,000 to get it down to 2%? What do you think? The higher the N, the lower the error. So is she gonna have to shoot more than 1,000 or less than 1,000 based on what we've already done? More than 1,000. Because at 1,000, she was at about 2.5%. We need more than 1,000 to get it below. So what we are going to use, we're still going to use we're going to use that number. We're going to use the P hat of 0.8. We're going to use the Q hat of 0.2. And by the way, and what are we going to use for error? 0.02. Because we want to minimize there. We want it to be 2%. We want it to be at most 2%. Not exactly 2%. So.
And the N is unknown.
And we're about to calculate.
I'm sorry.
Yeah, the N is what we're trying to find in this case. So we're going back to this formula here. All right. So in my numerator, I have 1.96, and I'm going to square it, times my 0.8, times my 0.2, over 0.02, and I'm going to square it. Now, the nice thing here is you don't actually need parentheses. You can just go left to right and then divide it by, you know, that's generally speaking, this is an easy calculation. Rosalind's not going to like this one. Tell me when you get a number. I have a number.
It's a high number, huh?
It's large. So what'd you get?
1, 5, 3, 6, 64.
We'll do 1,500 free throws. Yikes. Now, can you shoot 0.64 free throws? No. So you, by the way, this is one of the rare times you always round up. Always up. Because if you round down, then your error is going to be slightly more than 2%. So if you round up, your error is slightly less. So the way we'd say it is at least 1,537 free throws. Sorry, Razi, you're going to be tired. We've got your book for the rest of the afternoon now. But if we said no matter, now it doesn't even matter what percentage she makes, we can get a confidence interval with an error of at most 2%. Now, when we say at most 2%, it could actually be less, right? Is it possible that the opinion poll is right on the button? They say there's an error of maximum 3%. That doesn't automatically mean it's 3%. Does everybody understand that? It's, I have a cushion, but what I viewed is still the most likely outcome. It's still the most likely outcome. So if she made 80% of her free throws, regardless of how many she shot, 80% is still the most likely outcome, but we're giving a cushion because it could have been a good day, it could have been a bad day. We don't know the difference because we only know what we observed. That's why you have the cushion. On the opinion poll, I did it perfectly. I had the absolute best way of doing a sample humanly possible, but I didn't ask the whole population. So it's possible that I got a few too many of one side versus the other. So that's why the cushion is necessary. But if it's, let's say it's an election that is really going to be really close, you would want that cushion to be very small. Otherwise, your information is just not very, very helpful. Okay. Does that make sense, everybody? Yeah. So let's do a slightly different one. Let's suppose you want to do an opinion poll. All right. You want to conduct an opinion poll. And I'll say opinion poll because that's about as vague and non-specific as humanly possible. But it has to be binomial in the sense there can only be 2 responses. Okay, it's not, I want you to rate the service at that restaurant. No, that's still on a scale of 1 to 10. That's not what we're talking about. Did you like it? Yes or no? Did you like the movie? Yes or no? Are you going to vote for this thing? Yes or no? It's got to be only a yes or no question. Everybody understand? Otherwise, what do you're having to measure things. I just want to count yeses. Those are my successes, if you will. So you want to conduct an opinion poll. Yes, no. That's it. It's yes or no. Okay. And have 99% confidence. We're going to use a different number finally. That the error is at most, let's say, 3%. I want to be really certain. I want to make sure that I've just included everyone. So this is probably going to be fairly large. So what Z am I going to use this time? If I want a 99% confidence interval, that means I want 1% total in the tails. That means a 0.5% in each tail. That's the Z005, which on your sheet or on the board was 2.576. So that's the one I'm going to use this time. I want to really be sure that I didn't miss anybody, is really kind of the idea. 99% is I'm going to include almost the most extreme cases possible. Now, you're going to conduct an opinion poll, but you have no prior knowledge. You're going to do this for the very first time. So which formula are you going to use? You're going to use this one because you have no prior knowledge. You don't know how many people are going to say yes or no before you start it.
Unknown.
Does that make sense?
Yeah.
Yeah. And I said, this is the most common. The Roslyn free throw situation is kind of obvious. We have history. So we'll use the history numbers. But most of the time, you probably don't have history. Now, if it's something like opinion polls that are being done on a regular basis, and the thing is, I'm still going to go out and conduct my poll, but what I need to know is, if I'd rather do it 1,000 people than 10,000 people. So please tell me how big my sample has to be. If I have prior knowledge, it's probably a smaller sample. If I have no prior knowledge, the biggest possible sample is when both of those are a half, by the way. Think of it, if it helps you think of it, 0.5 times 0.5 is bigger than 0.4 times 0.6. It's bigger than 0.3 times 0.7. It's bigger than 0.2 times 0.8. Oh, as those separate, that product is smaller and smaller and smaller. 0.5 times 0.5 is the biggest this can ever be. So this is kind of like saying it's the safest.
Okay.
Because I want to make sure that I'm not missing anything. So in this case here, we're going to use that formula. So I want the n to be what? In my numerator, I'm going to use this number, 2.576. I'm going to square it. And in the denominator, it's going to be 4 times. I want an error of no more than 3%. So 0.03. And I'm going to square it. Okay. By the way, here's the cool thing about this type of question. It doesn't matter if you were saying Mesa College, the state of California, the United States, the world, the solar system. It's the same thing. The N you get, it doesn't matter how big the population is. Isn't that crazy? It would not matter how big the population is because you're basing it on simply the simple formula. So if you're doing national or local opinion polls, you still use the same N because it only depended on the size of the arrow. So what number do you get? Anybody?
I got a quick,
What'd you get?
1843.271.
Good, 1843.27. Now, this is people. Can't really have decimal people. And I said when it came to sample size, you always round up, because if you round it down, then the error is going in the wrong direction. So in words, you say at least 1844. If this were a national opinion poll and you wanted to know what people thought, and you wanted, first of all, you're going to put a limit of 3% on your error, but you want to be 99% certain. You want to have everyone say, wow, these people really get it right. Then you've got to poll at least 1,844 people. Now, in a country of 340 million, that doesn't sound like an ominous task, does it? To ask 1,844 people nationally? Now, you're not running around the country asking people. You might have people all over the place asking, people who work. Now, this one you'll enjoy. It was 1948 election. I want to make sure I got my dates right because this is historical. You can look it up. One of the classic opinions, have you guys ever seen the newspaper? It says Dewey wins, President Dewey in 1948. So wait, there isn't a President Dewey though. One of the largest polls ever conducted, and they asked him, and it's a classic. People have this headline: Dewey didn't win, Roosevelt won, and he won big, because in the polling they called people up. It was one of the largest polls ever conducted, and people were called at home to ask who you're going to vote for president. This is classic. Now, in the 1940s, the Great Depression just ended. Who had a phone? Who had a phone in the
Rich people.
Only rich people. Dewey was the candidate of the rich people. Dewey won in a landslide. No, Dewey lost in a landslide. Now, there was a pollster who went out and collected a smaller sample and published that Roosevelt was going to win in a landslide. Nobody paid attention to him until after the election. His name was George Gallup. What is the name of every poll you've ever heard in your life called? A Gallup poll. He was a statistician who understood the mathematics of what we're doing. He got it absolutely correct. And from that point on, that's the only poll anybody ever trusted, because it was how it was done. George Gallup has been dead for a very long time. But whenever you hear of a Gallup poll, it automatically lends trust, because it means they did it in an unbiased fashion.
I see.
Can it still be wrong?
Yes.
Yes, because you didn't ask everybody, but it's far more likely to be right because of how it's done. Yeah, O'Shea.
Was it like one of those groceries when the championship was like that?
I'm sorry. Say again.
The guy didn't win, right?
He didn't win, but they based it on the poll before the election.
So,
But would you say it was a biased poll?
yes, but.
Kind of, yeah.
It made it seem like, okay, you put the president, but you actually did it.
No. But the irony is that it actually made it to the newspapers because they did the poll, so close, and they got, we got this, we nailed this, and no, you didn't.
You only ask rich people.
You asked people getting off the bus if they're taking public transportation. I mean, you ask people at Burger King if they're vegetarians or not, like, there's certain things that should be obvious, but sometimes it's not till after the fact we realize, oh, that
Yeah.
really wasn't a good way of, and that's why this is one of the areas that people don't trust. People don't trust things like opinion polls for the obvious reason. They didn't ask you. But if it's done correctly, and we've talked about, that was how we started this class.
Yeah.
If we talked about sampling being unbiased. And by the way, sampling it's a science in and of itself. How do I do it correctly and the most accurately to make sure that my sample represents the population? That's why stratified was so important. Again, if I'm going to conduct let's just say it's a political poll, and I realized later that 90% of the people I asked were women. I did an absolutely random unbiased sample, but it ended up 90% of my sample was women. Can I absolutely trust the results? Well, it depends on what I'm asking.
That's true.
But what if the results are something that males and females might differ in opinion on? Then I have an extremely biased sample, don't I? I want to ask a question about, let's say, just simply about voting, about something voting in general. And I asked a sample and it turned out half the people I asked were under the age of 18. That's not a very good sample because they can't vote.
Yeah.
Oh, yeah, there are some red flags that should, so people tend not to trust polls because they didn't ask you. But I'm just the opposite. I know how it's done. And except if they really mess it up, and a lot of times you can tell because of the error, the error of plus or minus 12%. Unless they really mess it up, I tend to trust them because I know how it's done and I know the mathematics involved. It's not an absolute science, but it's like Rosalind's free throw shooting. We observed 80%, so 80% is probably the safest number to go with. Now, a cushion is even better because now it's almost certain that you're in that window. The chances of you being, when we made a confidence interval around your true percentage, the probability of you being outside that window is what the tail probability is. When we did a 95% confidence interval, then what's the probability we got it wrong? Only 0.05. That's why we're really, really happy. So when we're doing the polls, what is the probability I get this wrong? Only 0.01. I'm pretty comfortable if you said I'm 99% certain I got it right. I'm very comfortable with that.
Yeah.
That's why it's not an exact science, but it is extremely accurate in general. Yes, it can be wrong. Because again, unless you asked every person in the country how they were going to vote, you can't be absolutely certain. So only after the election do you have absolute certainty because everybody who's going to vote voted. But before the election, does that help at all?
It does. I translated it into like consider the source. So if the Avocado Corporation put out a poll, I mean, it's going to.
Yeah, you're right.
I learned that in nutrition class. It said
Can you
consider
have
the source of.
I have a son who's an absolute health fanatic, and he wants to become a doctor. He's doing all this, and anytime we'll have a discussion on something, I'll say, "Well, I was reading online about this." Yeah, but what source did you read?
The source?
And I always say, "Well, I'm trying to check the sources," and then he's got very strong opinions about certain things, and he'll say, "Well, anytime anybody writes anything bad about it, it's usually because they have some bias against it.
Yeah.
Maybe they're marketing their thing."
Yeah.
And he's right. And a lot of times we are flooded with information, and trying to discern the truth is difficult.
Yeah.
It is difficult to know what is true and what is not true. Let's take something as simple as the healthcare industry. I mean, do you take supplements of any sort?
Yes, I do.
None? Okay. My son is a big creatine guy. He's always trying to sell me on creatine. And I'm like, well, the jury's still out on that. He goes, no, it's the most researched supplement on. And then I went on the internet and I showed like the first 50 articles were all against it. He goes, yeah, but look who's writing them. I said, well, you're absolutely sold, but what articles are you reading? Yeah, I go, it also works both ways. You're saying all these things are against it, but the ones that are all for it. And so I talked to my doctor directly. Because I have joint issues, and I was asking, does it help? He says, no, not for that. There's certain things it's good, certain things it's not. But it's something I'll use that as an example because that statistically is one of the more studied things around. It's been around for a long time. But there's still no absolute certainty because there's way too much opinion.
Mhm.
And that's true with supplements are a perfect example of things. You can ask two healthcare professionals and they can absolutely disagree.
Yep.
And so it's one of those things where you as the average person, you can't be certain often. So you have to, you're right, you have to consider the source and you have to be able to read through things and
Yep.
say, what exactly is going on
Yep.
here?
It's crazy because when you get into an accident and you take whoever is driving with you or whatever, it's recorded, you get to pay a medical professional to explain to the jury why they were the reason you got hurt. But the defendant also does the same thing and pays their medical
So
professional.
who's more convincing?
Yeah.
I'm gonna give you one anecdotal situation with the opinion polls. Okay. Just so you know, I am not a baseball fan. I grew up as a baseball fan, but I'm not a baseball fan. I haven't watched a baseball game since they canceled the season in '95. I had tickets to the Padres and it took a year and a half for me to get my refund. Yeah, I haven't watched, I don't care, but I am very interested in scandals. I find particularly the steroid scandals going back to the '90s. I just found them compelling. So it was a very interesting situation. And this information was not supposed to be released to the public, but it was anyway. A certain percentage of baseball players got tested for performance enhancing drugs and a certain number came back positive. So the league said, this is the percentage of people in baseball using, and it was a really high percentage. The baseball union came back and said, no, this is the percentage using, and it was a really low percentage. And their argument was going back and forth about testing and the severity and the punishments, because there were no punishments yet. And I was teaching stats and my students said, how the heck can they possibly come up with such absurd different results? I said, oh, they're both right. Because they only tested a small percentage of players and a certain percentage tested positive. So what you do, you had to make a confidence interval around the true percentage. And so the league took the high end and the Players Association took the low end. And the high end and the low end, it was like literally from like 5% to 30%. It was such a huge confidence interval. Why? Because the error was huge. Why? Because the sample size wasn't all that big. In other words, they were both telling the truth. If I said somewhere, the number of players using is somewhere between I don't remember the numbers exactly. Let's just say between 5 and 30%. Wouldn't you say, I'm probably going to go somewhere in the middle would be safest? No, the players said the low and the league said the high. Now, I find that very interesting because I find the same thing is true during elections. My wife and I have this really funny habit we do that no one else does. We actually read the voter's guide, which isn't an opinion. It says, here is the financial ramifications of this proposition passes. It's not one side or the other. Here's what it says. Here's what's going to happen. So all of you, we're too far from an election, but you guys probably remember this. Okay, here's what's happening. Proposition, call it whatever, Proposition 100. You'll see, usually it's a little child running through a field with butterflies and your music, and if this passes, you're going to have more money in your pocket. The sky will be bluer, the water will be clearer. Everybody will be happier. It's like everything. It's basically paradise. And you're like, what person would vote against this? And then immediately after, there'll be a commercial. It's dark gray, smokestacks, a certain scene from Terminator 2, after the destruction of the earth. You guys have all seen this commercial. The smokestacks, the black sky, and Proposition 100. If it passes, it will be acid rain. You will have boils breaking out all over your body. Everything basically nightmarish, Terminator 2, what is that? Judgment Day. And you're going, what person would vote for this? And then you realize you watched consecutive commercials for the exact same proposition. If you pay attention, this is going to happen every single day, multiple times a day. And you're saying, wait a minute, one just made it sound like paradise on earth, the other doom and destruction, and then the same thing. And then my wife and I will read the voter's guide, and what they say is probably right about halfway in between those two things. What they both did in each case is took, if this passes, what is the most extreme that could still conceivably happen? And then they'll tell you the extreme. So are they lying to you?
No.
No. Are they representing it accurately? No. But it's the side for versus the side against. And if you pay attention, which I always do, I always laugh because the actual truth is neither. It's probably right about, if you could average paradise and judgment day, and that's probably what's really going to happen. But the point is, when there's a confidence interval. The extremes are mathematically possible, but people tend to manipulate and only report the extremes because they have an agenda. It doesn't matter which side of the fence you're sitting on, you just have to be aware they are using statistics, but they're using it, to their advantage in a sense. So we don't have anything going on right now, but I have so much fun during elections when I see the absolute extreme, the doom and destruction. There's always a doom and destruction one, and you're going to be out of work. They're going to take your house away. You're going to be deported, even though you're a citizen. Just everything bad's going to happen to you. You go, but I'm looking at the voter's guide, and that's not even in there. Okay. All right. We are done. We are done as done can be. We've also